Welcome to Investigation 2.1. This is modeling linear data patterns. In this investigation, our focus question was, how can you find a linear function that is a good model for a set of data and then measure the accuracy of that model with residuals? So this was the whole concept of looking at predicted data versus what actually happened and finding that error. So we are going to find that error with a new set of data. We have some data for the Columbus bus fleet, and in here you can see that we have the bus number, so they were on a particular route, the amount of gas that they used, and then finally how many miles that took them. I have also created a table with our awesome CMP student software, so if you wanted to, you could create this sort of graph using the math tools that are there. And with this, I looked at this point right here and this point, I'm moving everything around, sorry, and this point right here. And in all reality, I could have also looked at this point. And if you notice, this is literally 0, 0. This is essentially saying that if a bus had 0 gallons of gas, it couldn't drive anywhere. So we are looking at this equation that I was able to create using this line of best fit, and we're essentially looking at miles is equal to 15 miles per gallon times gallons. And notice that 0 is in there for the y-intercept, and these 2 points correlate with each other. So depending on how many gallons of gas, we can figure out generally how many miles this bus drove, or a bus would be able to drive. So with our investigation, we looked at, I'm actually going to change this up. We looked at how far or how much a bridge could potentially hold given a specific amount of data and given an equation. So in this case, we're going to be doing the same thing. We have a generalized equation. We have a table of values based on our independent variable. That's what we're going to be looking at. And we are primarily paying attention to what comes out of this thing through for our dependent variable. So let's write down these the dependent variable information. So really quick, I'm going to fill in this table with some information. Hold on a second. And magically it's there. Here we go. So we're looking at actual versus predicted. The actual amount that these buses had are here in the table that I've added. And no, I did not add all of the points. I can also do 320 and 375. And I probably will in a moment, but I only had room for this. So predicted based on our model, for 5 gallons, the actual was 80, but in this case we need to do 5, or we need to figure out what it could have been, or what it should have been. So we have miles is equal to 15 times 5. 15 times 5 equals 75, so I'm going to put that in my table. Predicted amount is 75. So that means the difference between our actual and our predicted is 5 gallons. 80 minus 75 is 5. Now we need to do that for every single one of these values. So now let's go on to 8. We have miles is equal to 15 times 8. So this time we have 120 as our answer, 120. So 100 minus 120 is negative 20. We need to do that for every single one, so I'm going to fill in all of this. Just one moment. So magically our table is starting to fill out. We have 180 minus 180, which is 0. 225 minus 225, which is 0. 280 minus 270, which is a positive 10. And 290 minus 300 equals a negative 10. So let's also finish this table off because I finished creating the rest of the math. So here we go. We have also 320 that we need to pay attention to and 375. So let's fill that in. So for 320 minus 330, we have again a negative 10. And 375 minus 375 is 0. So in all reality, our residual is not looking that bad. We can add all of this stuff up. We have 5 plus a negative 20 plus 0 plus 0 plus 10 plus a negative 10 plus a negative 10 and plus 0. So looking at all of this, we'll end up with a negative 25. And if we were to divide that up amongst all of our different data points, we have 1, 2, 3, 4, 5, 6, 7, 8 different data points. So negative 25 divided by 8, we get negative 3.125. That's not too far off. And if we were to look at our actual, whoops, I wasn't supposed to do that. If we look at our actual graph again, we can see that the points aren't very far off the line. And in all reality, we have 3 points that are on the line. Actually, almost 4 points that are on the line. 4 points? 3 points, something like that. 1, 2, 3, 3 points that are on the line. This one's not. Regardless, we can see how residuals can help us model a line of best fit and see how far off we are in our predictions. This is a pretty good prediction for the bus data, especially considering it's going through the 0, 0 point and it's hitting 3 points on the line as well. So, in this investigation, hopefully that helps you see how to model some linear data patterns. I hope this video helps, and good luck on the quiz tomorrow. Signing off, this is Ms. Beardsley. If you have any questions, make sure you email me tonight or ask questions during class. Thank you.